Once again, I welcome all the participants for this webinar. Today, we are going to cover, I'll be covering the three important topics related to a gearbox, is a part of a transmission. I will be speaking about design of a gearbox, and then the development activities happening in an industry related to a gearbox, and then what are the different type of testing which is being carried out in an organization related to a gearbox. I will be covering transmission as well. At the same time, I will be covering parallelly with respect to gearbox as well. The content of the presentation is, it involves the various topics. First, I will be starting with introduction types of gearbox. Then I will be covering about design of gears. What are the parameters that they are considering to design a gear? And then what are the different development you need to consider when you are going for a gearbox? What are the different failures that we can expect with respect to the gearbox, and then different failure modes of gearbox. Finally, I will be covering the topic, very important topic called testing of gearbox. What are the different type of tests that are being carried out for a gearbox, basically for the transmission purpose. Okay, so these are all my contents. First topic is going to be the introduction and types of gearbox. So these are all the different transmission designs that are available. Because this vehicle is being classified as various category: land vehicles, vessels category, and also aircraft category. So we are going to speak about the land vehicles. Okay, it involves the vehicle which is running in roads, and some of the construction vehicles, agriculture vehicles, and even some of the special purpose vehicles, and even the rail vehicles as well. And again, when we are speaking about a road vehicle, it is again having different category into it. And again, here, when you are going for a road usage of vehicles, we have a gearbox. We have to select a gearbox where we'll be selecting the gears, and we also have a transmission system which involves not only gearbox but also the final drives, differential gears, transfer boxes, or in the case of a tractor, you have a power takeoff, PTO, you call it in short, and you also have the steering boxes. And this is also applicable for a construction vehicle as well. And today we are going to cover most of the topic related to gearbox. And with respect to testing point of view, I will be covering the generic test which has been carried out not only for gearbox but for a complete entire transmission. Coming back to the important topic, the transmission types. We have different types of transmission. First one is going to be the automatic transmission, shortly called as AT. Then manual transmission, shortly called as MT. And you have a combination of automatic plus manual called as AMT, which is nothing but automated manual transmission. And the next one is going to be a CVT, which is called as a continuously variable transmission. And again, with respect to the transmission, as I said, you have two important category: manual transmission and automated transmission, and even you have the combination of both called AMT. And you have different types into it. You have a constant mesh transmission, synchronous transmission. Even you have a sliding mesh transmission. But nowadays we are going either with constant mesh or a synchronous. And again, in AMD also there are different category where you have either semi-automated constantness or synchronous, or it can be fully automated. And very important topic where automatic transmission comes into picture, where you have DCT called dual clutch transmission, and you have a transmission with the countershaft type, and you also have the conventional automatic transmission as well. And this is a very interesting topic. When I say transmission, automatic transmission, it involves a gearbox again. So it is going to be automatic gearbox. So when I say a manual transmission, it is going to be a manual gearbox, where it can be either of a constant gearbox, or it can be either of a synchronous gearbox. And again, you have different category for different vehicles running on road. It can be with respect to hybrid vehicle or electric hybrid vehicle or electric vehicle. Accordingly, you have different types as well, and according to that different category, you have the transmission for those category of vehicle as well. And you have one more important transmission called CVT, called continuously variable transmission. And again, it can be either operated through mechanical means or by hydraulic means. And when you're going for a mechanical, it can be through pulley, the power gets transmitted, or it can be of toroidal transmission. And hydraulic is by hydrostatic transmission. And yeah, this is the thing. And where in the case of you go for a manual gearbox, you go with a manual gear shift, and in the case of automatic gearbox, you go with the automatic gear shift. And again, you have automatic torque and speed conversion when you're going for the AMT or AT. Let us see on video with respect to the different type of transmission, basically the gearbox, and then we will go to the slide.
Welcome back. You're watching Automobiles. In this video, we'll tell you all about the various types of automatic transmissions that exist in the modern day automotive world. We'll tell you how each of these differ from each other, and at the end of this video, we'll tell you which one to choose based on your specific needs. So with traffic getting worse and worse with the day in India,
Sir, audio is coming, sir. It is playing, sir. We can proceed, sir.
most of us are opting for automatic transmission variants when we want to purchase a new car. Although these variants come at a premium than manual transmission variants, the convenience these offer is really worth all the extra moolah you're shelling out. So let's try to see what are the various types of automatic transmission that are available in Indian cars today. We have torque converter or conventional automatic transmission, AMT, which is automated manual transmission, CVT, which is continuously variable transmission, and DCT, which is dual clutch transmission. Now let's get into the details of each of these. Let's begin with the traditional automatic transmission or torque converter automatic transmission. The conventional automatic transmission or AT remains the most popular, most common form of automatic transmissions globally. Torque converters have been around for a really long time now, and as a result have become quite reliable. The AT makes use of a torque converter to transfer the power generated by the engine to the gearbox. Torque converters are made up of three main components: impeller, turbine, and stator. These three components lock and unlock with the help of multiple clutches and maintain predetermined gear ratios. However, conventional ATs can sometimes take away a fair bit of power, resulting in power losses in the drivetrain and also provide poor fuel economy compared to regular manual transmissions. The positives of a conventional automatic transmission are smooth gear shifts and reliability. In terms of negatives, fuel efficiency is lower compared to other types of gearboxes. Next up, let's talk about AMTs. AMT or automated manual transmission is one of the simplest implementations of an automatic transmission and is also the most cost effective. It was popular during the 1970s in countries abroad. However, with advancement in technology, the AMT gearbox has made a comeback in emerging markets like India. The AMT is actually a regular manual gearbox, but with the addition of an electro-hydraulic system which comprises of an electronic control unit and a hydraulic system. This system, which is also known as the Transmission Control Unit or TCU, monitors parameters like accelerator pedal position and vehicle speed, among others, and controls the hydraulic operations, which changes the gears automatically without the driver needing to use a clutch. Some AMTs also offer a manual shift mode where the driver can change gears by using the gear shifter without having to use a clutch. Due to their cost effectiveness, it is mostly found in budget cars like the Hyundai Santro, Maruti Wagoner, Renault Kwid, and so on. In terms of positives, we can see that AMTs are the most cost-effective transmission compared to its counterparts. AMTs are also known to deliver high fuel efficiency, something at the level of manual transmissions. In terms of downsides, AMTs are known to have slower gear shifts, and they are also not smooth and produce a gear shift sound that you often hear in manual transmission. Moving on, let's talk about CVT or continuously variable transmission. CVTs are one of the most refined automatic transmissions. The CVTs use steel pulleys and a belt that can generate infinite gear ratios. This means that there really are no gear changes as such, leading to smooth, seamless power delivery. This type of transmission is very quiet too, and is widely used in gearless scooters in India. However, CVTs can feel a bit elastic when you drive them, especially when you notice what is called a rubber band effect. Premium cars like the Hyundai i20, Maruti Baleno use these types of transmissions. CVTs can also get paddle shifters to give them a sporty appeal. In India, Honda cars like the Jazz, City, and Civic offer paddle shifters with their CVT. In terms of their pros, CVTs are known to have the best fuel economy among all automatic transmissions. They also have really smooth operation in stop-start traffic situations. In terms of cons, CVTs suffer from a rubber band effect when revved really hard, and CVTs are also known to have slow acceleration. Let's now talk about DCT. A dual clutch transmission or DCT uses two separate shafts with their own clutches for gear shifts. One shaft for odd numbered gears and the other one for even numbered gears. This type of automatic transmission provides really quick shifts and also delivers good fuel efficiency. However, since the technology involved in the system is fairly complex and consists of a number of electronic components, the costs associated with manufacturing a DCT is relatively higher, which is also the main reason for its lower level of adoption. Maintenance costs are another area of concern for DCTs. Cars like the Volkswagen Polo, Volkswagen Ameo, Skoda Rapid, Skoda Octavia are all available with dual clutch transmissions. Thing to note, Volkswagen has its own variant of the DCT which it calls the DSG or Direct Shift Gearbox. In terms of positives, DCTs are known to have lightning quick upshifts and downshifts. They also have great performance and fuel efficiency. But in terms of negatives, DCTs have higher manufacturing and maintenance costs, and they are heavier than other transmission options. So which one should you choose given an option? Well, if you're looking for a low-cost gearbox that is also cheap to maintain, you may go for an AMT. Fuel efficiency on AMTs are at par with their manual counterparts and is yet another reason why you may go for an AMT. That said, if you're looking for the best possible fuel efficiency, then the CVT has got to be your pick. Not many manufacturers offer a CVT these days, so that could be a concern when you're looking for your next car. And if performance is of utmost importance to you, then you've got to choose a DCT transmission model. DCTs are quick to shift and have minimal to no loss in power and torque and do not compromise on fuel efficiency as well. But then again, all of this comes at a premium. So that was our video on the various types of automatic transmissions available in India.
Yes, we have seen a video which covers various types of transmission which are available, and We have also seen the advantages and then the pros, cons of different types of transmission which are available as well. We have seen those things. And I'm pretty sure that this would have given you some overview. And now let us go to some of the basics. First we'll start with a need. Why we need to have a gearbox, basically. Let us go with the basics. The need of the gearbox. Okay. So here, when I say the need, here it is basically the gearbox is being necessary to able for regulating the power output at the same time the speed range of the engine. Okay, with respect to the range of the speed over which the vehicle will be moving at a given period of time and whenever it's required to operate. And again, with the help of a gearbox, the driver can also regulate torque by selecting the appropriate speed range or the vehicle speed at which the maximum torque is obtainable. Okay, so this is one advantage that you have when you're going for a gearbox, and that's why the necessity has become a very important thing with respect to the gearbox point of view. And this is the known fact for to all of you. You have three type of forces which is acting in the vehicle, and these three forces are going to oppose the movement of the vehicle as well. So you have the aerodynamic force because of the air, and you have the gradient force, and then the important force, the third important force called rolling force. Because of this, you have a lot of opposing movement to the moving vehicle, and you need to consider all these forces, and you need to look considerably to increase the power of the vehicle or the output torque of the vehicle basically. So here, let us go to the aerodynamic force. So here, as I said, aerodynamic force is related to the air, and this here the air is going to offer a resistance, which is going to resist the movement of the vehicle. And here it can be through some of the medium. So when I say some of the medium, here the medium is going to be air, and where we also have some other medium where as a restriction what we have, or as a water or some other fluid like that, you have air as a medium for you to resist the movement of the vehicle. And again, the magnitude of the resistance which is being made by the air flow is also depends upon the shape of the vehicle and also the front area of the vehicle body basically. And it also based on the vehicle speed as well. So all this will contribute to the magnitude of the resistance. And this is when the vehicle speed is higher, you can see the air resistance is going to be higher. And this graph will give you an overview that the air resistance is directly proportional to the square of the velocity of the vehicle. And again, you have the air drag, which becomes very significant when the vehicle speed is going to be with 70 km per hour. And below this 70 kilometers, we neglect basically the drag basically. And next is going to be the gradient force or a gradient resistance force. And here the resistance is offered by the road. And this gradient resistance is dependent on the steepness of the slope, and it is affected, and it is been unaffected by the speed of the car as well. And this is the factors which determine the gradient force or the resistance force due to gradient. Basically, when you move the vehicle up the hill, it depends on the angle. It also depends on the force which is going to get acting onto the vehicle when the vehicle is going upward up the hill. And we have a very next important force called a rolling resistance force. And again, when you're taking the rolling resistance into consideration, you are going to take energy which is getting dissipated at the tires and energy loss in the transmission. So our focus is also here where you have different type of losses in the transmission as well. And again, but again, when comparing to the losses with the tire, the loss in the transmission is going to be less. Okay, so again, between the tires and transmission, our area of concentration or focus will be towards the road and then the tires. Okay? And again, a different type of roads will also cause a different type of energy getting dissipated into the tires. Say, for example, if the road is soft, accordingly, the tire will cause a larger dissipation of energy when comparing to the hard roads. And again, coming back to the soft road, the wheels are in effect, and again, they have been continuously driven up when the road is going to be very soft, and you have a ramp to lift the vehicle out, and then you also have the wheels which will have some sunk characteristics as well. And this is the total resistance, which involves the three parameters what we have seen so far, and it also increases when the vehicle speed is getting increased. And again, this is the total resistance versus speed, and again, it also varies with respect to the different surfaces as well. As you know, the resistance force gets increased when the speed of the vehicle is getting increased. This is what the graph is also shown here. And again, you have very important graph where you have x-axis, you have a vehicle speed and you have the tractive effort, and you can see the behavior with respect to the tractive effort, how it is getting increased and then it is getting decreased with respect to the different velocity of the vehicle basically. And when you take off of the vehicle speed, where you get a curve which is increasing and then it is getting decreased, and you get the torque is 2 times higher when the velocity is going to be off, which means I will just explain you with the help of one more graph called the vehicle speed, same with respect to the total resistance and then the tractive effort in terms of Newton. So when I say the force, it is going to be in terms of Newton. And again, here you have various curves. Okay, let me go to the important analysis out of the graph. So you know the power is defined as the product of tractive effort. Okay, what we have seen in the last graph is a tractive effort, or it's the force in Newton into the speed, which is nothing but in RPM. You get power, power is nothing but 2 pi nt by 60,000 you call. And again, we have seen that the maximum when you have this velocity, when it is off, you get 2t, right? We also seen in the previous graph. And when you are taking the tractive effort into consideration, this tractive effort is inversely proportional to the vehicle speed or the road speed. Say, for example, when the vehicle speed is higher, what happens to the tractive effort? It is inversely proportional. And accordingly, the graph what we have seen is also been plotted accordingly. And again, you see the very important thing is that the tractive effort curve, when we are considering, it is been increasing and then it is getting decreased. And again, you see, it also depends on the vehicle speed as well. Okay, that's what I have also explained. That also depends with respect to the vehicle speed, where it is inversely proportional. And it is very important. The observation what you are going to get out of the graph is the power, the tractive effort, and then the speed of the vehicle. This analysis you are going to get out of that, and accordingly you are going to ensure that you are going to meet the required force or the resistance which is required for you to achieve a particular torque which is required for the vehicle to perform in a normal road or in a hard road or in a soft road or in the road which is climbing the hill or down the hill. With respect to different condition of the vehicle, you need to perform considering the different aspects. Let us see the importance of a gear ratio. So we have seen the gear. We know that the gear ratio, which is defined as the ratio between the input speed or the number of teeth to the output teeth or to the output speed, basically. Number of teeth in the output shaft means output gear, basically. We also have drive gear and driven gear. And when you divide the input by output, we get gear ratio. So this is just an example. When you have the driving gear, which is going to be 25 teeth, and driven gear, if it is going to be 50 teeth, then the ratio between the driving and the driven is going to be 25 by 50, which is going to be 0.5. It means for one revolution, it means for one complete rotation of the gear, the output gear will be rotating, or it will be rotating off of the times, basically. And yeah, we have the different category of gearbox. When it comes to the manual gearbox, okay, we have a different gear category, like it can be a 5-speed gearbox or even 6-speed gearbox. Even the same when it comes to some of the AMT, automatic manual transmission, same type of gear selection is there. And when it comes to the automatic transmission, you have the similar configuration. At the same time, you have the gear shifting, which is going to happen automatically. And the last important aspect with respect to the gear number of gears, even in the case of the race cars or some of the high-speed cars, where you also have some of the gears, even you have up to 8-speed gearbox as well. Even some of the vehicles like Volkswagen, they also have some of the applications. For some of the applications, they use up to 8-speed gearbox as well. And when the number of gears is getting increased, okay, the gear ratio will get decreased, which means we have seen the gear ratio, right, in the previous slide, which is defined as the ratio between the driving gear to that of driven gear teeth, or I can even tell in terms of speed also. Okay, now here I'm going to consider the teeth, and accordingly I'm going to have this ratio, and this ratio is going to get decreased when the gear is going to be on the higher side. So when you have the top gear, the gear ratio is going to be 0.7. So just an example. And again, at the same time, the speed, when you consider the speed, okay, here we are going to consider the RPM of a gearbox output shaft, okay. And again, you have a different speed, and you have the engine speed, which is nothing but the N1 by N2. N1 is going to be 3000 and N2 is going to be 4065. So when you divide 3000 by 4000, you get this value. Okay. Similarly, when you divide 3000 by 947, you get this value. Okay. And this is nothing but input speed to that of the output speed, or driving to the driven, or the driving teeth to that of the number of teeth in the driven gear. Okay. And this is the scenario. And you have, this final reduction gear in an automobile, where you have this reduction gear in the differential, and this final gear reduction is very much important, where the range is somewhere between 4 to 6 is to 1. And here is the final reduction gear. From this gear, this directly goes to the wheel, and it will also determine the actual velocity of the wheel as well. And I have one more video for this sliding mesh gearbox and constant mesh gearbox and synchro mesh gearbox. So we have.
Sir, excuse me, sir. Sir, my connection got disconnected, sir. Can you give co-host for me, sir? I have joined. Yeah, yes, sir. Okay, thank you, sir.
I will. Yeah. And let us see with some of the videos I have. I will just show to you. And these are different type of gears you have, and the first gear, second gear, third gear, and then fourth gear. You will see all these things, and this is the reverse gear. All these basics you know already. And this is the constant mesh gearbox layout. And this is the 5-speed constant mesh gearbox, where you have the different category, layout, where you have the clutch. You have the first gear, second gear, third gear. You also have the selector fork to select the gears, and you have the dog gear as well. And you have the fourth gear and fifth gear as well. And the very important thing, this has been, you also have the counter shaft, the lay shaft here. And this is the synchro mesh gearbox. So you have 3 types. One is sliding mesh, constant mesh, and synchro mesh. And where in the case of synchro mesh, you have a synchronizer ring. It's basically a cone shaped synchro collar shape, and it engages the gear, which is here. The gear is considered to be helical, and it will bring the dog gear to the required speed basically. Let us take the tractor gearbox, which is having 3 different types. Let us understand what is the difference between a sliding mesh gearbox, constant mesh gearbox, and a synchro mesh gearbox.
Hi all, good morning. So today we will see about the type of gearbox used in the tractor industry. So totally sliding mesh type of gearbox, constant mesh, and synchro mesh. There are 3 type of gearbox used generally in the Indian tractors. So let us have a look on that one by one. The first one is the sliding mesh gearbox. So this is sliding mesh gearbox, where there will be one input. This is engine side, and there are 2 outputs. So this output is to wheel, and this output is for PTO. So in this gearbox, this is main shaft and this is counter shaft. The gear arrangements are like this. So the gears of counter shaft and main shaft not in mesh generally, normally. So whenever we are shifting the gear, whenever we are moving the shifting lever, the coupler is connected to the gears. So this coupler is connected to this main shaft gear, it's an integral part. So whenever we are shifting the gear, the entire gear will try to come and engage with this gear, counter shaft gear. RPM of these 2 gears are different, but still we are trying to engage these gears. Mean what will happen? The gear to gear, there is a more possibility of gear to gear clashing. So that will make hard shifting, noisy shifting, and chance for gear damage is much higher. So this gearbox is having these drawbacks. So that's why we are not using in our current power track and farm track tractors. So many of our competitors are using this sliding mesh. Next one is the constant mesh type of gearbox. Here, the main shaft gear and the counter shaft gear, you can have a look here. The main shaft gear and counter shaft gear, these two gears are constantly in mesh. In between two gears, even in between these two also, or in between here also, you can see there is one coupler. Coupler, and this is the sleeve of this coupler. So this coupler is placed in between. Whenever we are shifting the gear, only the coupler is going and engaging with the dog teeth of the gear. These gears will come with the dog teeth. The sleeve will engage with the dog teeth so that speed of the gear is transferred to the coupler, then coupler speed is transferred to output shaft. So entire gear is not sliding gear in this case. So only the coupler is going and engaging with the dog teeth of every gear. So smooth shifting is ensured, less noise will be there, and life of the gears also much better. That is why most of our models we are using constant mesh gearbox. There is one more type of gearbox available in the tractors, that is synchro mesh. So this synchro mesh is, we can say it's a improved version of the constant mesh. Primary shaft and secondary shaft, both this shaft, gears are meshing actually, constantly in mesh. But in between these two gears, again here also there is a coupler, but this coupler is called as synchronizer. This unit is called as synchronizer coupler or synchronizer. So in this synchronizer you can find there is one ring gear. So this is a synchronizer unit. There will be a one ring gear, and as well as this is the cone. This part is the cone of the gear. I'm just showing it to you. This cone is a part of a gear. This ring is a part of a synchronizer. Once we are engaging the gear, during the engagement, initially the ring will come and contact with this cone, taper surface. So it will synchronize the speed of synchronizer and as well as the gear. Since the speeds are equal, as a next stage while we are shifting, first ring is having the contact with the cone, second is synchronizer sleeve will engage with this dog teeth. So what is the advantage? Smooth shifting is ensured because it's syncing the speed first, then its gear is getting engaged. Smooth shifting is ensured, less noisy. So this is generally used in higher end tractors. We are using in some of our models. So this is about all the three type of gearbox generally used in the tractors. Thanks for watching. Subscribe our YouTube channel to get more such videos. Hi all, good morning. So today we
this the dog gear. Basically, we have this which is being used in manual automatic transmission as well to lock different gears. It's basically used for locking the different gears to the rotating input and also the output shaft. And you have the synchronous arrangement as well, right? Which will ensure the smooth engagement by matching the shaft speed when it is also making to engage as well. And again, you have this dog gears. You see here how it is getting engaged with respect to different gears when it is in the neutral position. Okay, and same dog gear when it is in engaged position, you can see how means it is getting engaged with the help of a salter fork. Will slide the dog gear either frontward or backward. Accordingly, the spine shaft will get engaged with respect to the teeth of the dog gear, and finally the engagement will happen. And this is how the layout when it is when the dog gear is in the engaged position basically. Um, you know this. You know the reverse gear. The movement of the vehicle in the reverse direction. So this is the layout where you have the reverse output shaft gear and you have the reverse layer shaft gear as well. The movement is going to be in the opposite direction. And you have very important gearbox or the very important thing called a crash box basically. Basically, this crash gearbox it uses a straight cut gears. You can see the gears is a straight cut shape, and these are normally used in vintage cars. The old cars would have seen. Maybe if some of the teardown has been done, you can able to see. This is how they look at. Even this also been used in some of the trucks, the large trucks basically, and even some of the racing cars also uses this crash gearbox basically. And here what happens is the speed of the engine will be matched to that of the gearbox before a gear is getting engaged. That is one of the advantage that when you're going for a crash kind of gearbox. And you have very important gearbox called sequential gearbox. It is going to have the gearbox which is sequential in nature. Let us see one of the video with respect to the sequential gearbox. It will help you to understand how the sequential gearbox is going to function basically.
How does a sequential transmission work? Let's untangle in this video. As the name suggests, in sequential transmission, the gear shifting is done in a fixed sequence, which means shifting in any consecutive gear is possible, but skipping gears as manual is not. The interesting thing to note here is that the gear shifts take place just by rotating one shaft. And just by rotating it at different angles, you can obtain different speed ratios. The sequential transmission is similar to manual transmission. The only difference is of the operating mechanism. This has all forks mounted on single shaft, while in manual there is only one fork per shaft, requiring multiple shafts for multiple gears. The sequential transmission has one more shaft, which does the work of shifting gears. This shaft has grooves on it, designed in a special way. The selector forks have pins on it, which mesh in these grooves. In neutral, all the forks are perfectly in center and not engaging any of the gears. The gear engagement is done by rotating the shaft at certain angle. As the shaft rotates, the groove position engaging this one pin shifts one side. This pushes the pin aside, sliding the fork. This engages the first gear. One thing to note here is that when one gear is engaged, the other grooves make sure that forks are in position of disengagement from the other gear sets. The grooves are designed in such a way that, after a specific degree of rotation, gear selected earlier disengages, followed by the engagement of next consecutive gear selected. The same pattern follows for downshift. These grooves ensure that, before shifting to another gear, the previously selected gear is disengaged. In some gearboxes, this shaft is eliminated and the shaft with groove is directly used here. The fork now slides on the grooved shaft. The pins which protruded from outside now protrude from inside. The working remains the same, while we get an added advantage of decrease in weight and space consumption due to reduction of one shaft. This shaft also has some safety mechanisms in it, like recessed surface with spring-loaded balls, to lock the shaft in place, ensuring it doesn't turn due to vibration, loosening the engagement. In motorcycles, there is a claw arm arrangement which does the work of rotating the shaft, which does the work of changing gears, while this same mechanism ensures the locking of the gears. Then there are pneumatics, hydraulics and electric motors used to rotate the shaft, which are electronically controlled in some cars. You can find this in most F1 cars. This is the same mechanism used in semi-automatic and AMTs, which are automatic manual transmission, with either a torque converter or electronically controlled clutches. The main advantages of sequential gearbox are super fast shifts, lightweight than automatic and manual transmission, compact in size, and easy to control via electronics.
Yeah, even this is also been used in some of the application with respect to the motorcycle or even for some of the racing cars. Okay, because in racing cars you need to have weight which should be lesser, lightweight. The speeding of the gear should be very fast, super fast in the case of racing cars. Okay, let us go to the very important, interesting topic called automatic gearbox. It is having the arrangement, having the sun gear in the center, and it is having the different planet gears, and then you have the planet carrier, and you also have a ring gear. So this is the arrangement of the automatic gearbox. Let us see how the automatic gearbox functions, or how it is been operating basically.
The most popular form of automatic transmission found in automobiles is the hydraulic automatic transmission. This system uses a fluid coupling in place of a friction clutch, and accomplishes gear changes by locking and unlocking a system of planetary gears. A simple planetary gear set consists of a single sun gear, 3 planet gears, a planet carrier, and a ring gear. Each of these 3 components can be the input, the output, or can be held stationary. Choosing which piece plays which role determines the gear ratio for the gear set. In first gear, the sun gear is driven by the torque converter, which is driven by the engine. The ring gear is held stationary by a multi-plate brake. The planet carrier is connected to the output and drives the wheels of the car. Thus a gear ratio of 3.4:1 is obtained, and the output speed is slower than the input speed. In second gear, the sun gear is driven by the torque converter. All the parts of the planetary gear set is held stationary, and the ring gear is connected to the output and drives the wheels of the car. Thus a gear ratio of 1:1 is obtained, and the output speed is equal to the input speed. In third gear, the planet carrier is driven by the torque converter. The sun gear is held stationary. The ring gear is connected to the output and drives the wheels of the car. Thus a gear ratio of 0.7:1 is obtained, and the output speed is faster than the input speed. In reverse gear, the sun gear is driven by the torque converter. The planet carrier is held stationary. The ring gear is connected to the output and drives the wheels of the car. Thus a gear ratio of -2.4:1 is obtained, and the output speed is slower than the input speed.
You also have a compound planetary gear. It is also the different arrangement, which is similar to the one what we have seen in the video, where you have a large sun gear and you also have a similar kind of arrangement, but you are going to have a sun gear which is of two different shapes. One is going to be with a large shape, another one going to be with small. You call it as a small sun gear. Okay. And when it comes to the compound gearbox or the planetary gearbox, the input is coming. The input is coming from the torque converter, and you also have a similar arrangement what we have seen in the case of your normal automatic planetary gearbox. In the case of compound gearbox, as the name indicates, compound, you have the composition of both small sun gear and as well as the large sun gears, which will in fact get in contact with the planet gears, and accordingly the transmission is going to happen with the help of the compound of both uh, small sun gear and then the large sun gear. So we have seen DSG, the case of a video we have seen. DSG stands for a direct shift gearbox. It is basically an electronically controlled dual clutch, multiple shaft automatic gearbox. It can be either a transaxle or a traditional transmission layout um, configuration basically. And this DSG it is basically the direct shift gearbox. It has been used in the case of a conventional automatic transmission as well. And this is the cut section of a DSG called a direct shift gearbox. This is how it looks when you do the cut section analysis. Okay, so we have seen different type of gear, first gear, second gear, or up to we have seen 5-speed gearbox or 6-speed manual gearboxes. Okay, this is basically the arrangement of a gear. This is the arrangement of the first gear, how it looks. You have a clutch housing which is connected to the engine flywheel. You have the dog gear, which is going to get engaged with the second helical gear, but not yet being driven. And you have the output shaft, and you have a dog gear which is going to get engaged with respect to the first helical gear. And similarly, when it comes to the second gear, the dog gear is going to get engaged with the second helical gear, and correspondingly, if it is third or fourth, accordingly it will get engaged. And again, you look at here when it is either in first gear or in second gear, what happens is the dog gear will again. In this case, the dog gear will get engaged to the next gear, but it will not be in a driven condition basically. It is not going to be in driven state basically. And again, this is all about an overview of complete the gearbox what you have seen. Let us see very important parameters with respect to design point of view called a transmission ratio. We have seen the gear ratio, which is defined as a ratio between N1 by N2, and here this is also defined as a ratio between N1 by N2, which is nothing but a transmission ratio. Here you are also considering the angular velocity omega 1 by omega 2, and according to this, the speed reducing ratio will when we have the ratio transmission ratio less than 1. You have a speed increasing ratio, and when it is greater than 1, you have a speed reduction ratio. When you have the speed reduction ratio, what happens is it is very good for when the vehicle is running at high RPM or high speed basically, and this is good for when the vehicle is running at medium speed or low speed basically. And again, you also have the value which is greater than 0 and less than 0. Accordingly, the direction of rotation of the output shaft will happen in line to the transmission application as well. So we have seen the gear ratio, and we also seen the gear for different type of gear, first gear, second gear, and third gear, fourth gear. What we have seen is we have seen when the number of when the gear is on the higher side, we have the low ratio basically, right? So that is what I highlighted here. So fourth gear is having a less ratio compared to the first gear. At the same time, when the vehicle is running at a first gear, you can see that the rotational inertia coefficient is also going to be higher. Okay, because you need to the resistance what is going to get acting is also going to be higher when you are in first gear, and when you are in fourth gear, both the rotational inertia coefficient and also the gear ratio is going to be lesser. This is the schematic diagram of the powertrain, where you have a front mounted range unit, and this is the main gearbox, and you also have a rear mounted range unit, and this is the clutch, and this is the engine. Okay, this is the layout basically. When you are considering the gearbox, so this comes into picture, and when you are considering the transmission, it's not only a gearbox but also the final drivers. There you have a transfer box, you have a differentials as well. So when we have seen attractive effort, the speed, and we have seen some of the graph. The same graph, it is represented in a different way, a different manner. See, this is with respect to velocity of the vehicle. This is the tractive power or traction power. See, when the vehicle is running at the fifth gear, what happens is the vehicle speed is also going to be higher. Correspondingly, when the vehicle speed is lesser, it is going to get operated in first gear. And again, the very important observation that you need to have here is with respect to the value called traction power. You can see for the same tractive effort, instead of telling the different values with respect to the power point of view or with respect to the force which is going to get acting onto the area. So what I'm going to say is, I can also put in another way. For the same tractive effort or the tractive power, the velocity of the vehicle, which is going to be higher, the speed is going to be higher for a fifth gear rather than comparing to the first gear of the vehicle. And when the vehicle is going to run in up the hill area, okay, so when the vehicle is, say for example, when you have a gradient, and when for which you normally run the vehicle in the first gear, and this also depends on the angle which is going to climb the hill or the gradient, and accordingly you need to select the gears as well. And again, you also have the acceleration corresponding to the gradient. And see, you for a normal road you need to have high acceleration, and again, where you can run up to the fourth gear or fifth gear or sixth gear, whatever it is. But when you're climbing the hill, you need to have the more torque at the initial stage. Okay, accordingly, you need to also select the gears basically. And these are the different cycles that we normally follow while we are doing the test basically. What normally in any organization we do is we do the testing with respect to the new European driving cycle or Indian driving cycle. We also have the worldwide harmonized driving cycle. Even we have different countries. Even different countries will also have different driving cycle, like Japanese driving cycle, European driving cycle. Apart from European, you have Japanese. Some other countries also have their own driving cycle, and we need to do this testing. We need to test whatever I have shown you, the transmission, different type of transmission, automatic, manual, semi-automatic, AMT, or DSG, or all these applications, Synchro, or whatever you have seen. Okay, so all this needs to undergo this type of test to ensure that the durability is not going to get affected and the performance is going to get met. And we do the different type of testing as well. And with respect to the transmission, not our topic today, but you have a transmission control unit which has been operated electronically, and here you have a different sensors to control the transmission basically, and you have a unit called a gearbox brake valve unit. And here you control the complete transmission. When I say transmission, it's not only gearbox but also the final drive as well. And again, you have the functions related to automatic or the electronically controlled transmission, TCU, you call it, transmission control unit. You have the functions related to the different application. You also have the programmable one. It's going to be a coding. You have that, and you're also going to develop the software for that. And in company, what we normally do is we do the function development and also we do the software development so that the transmission is going to function properly. And this is the layout of automatic transmission. What video we have seen, even you would have seen some of the vehicle which is going to have the same configuration. It is going to have the configuration, the different location for shifting the lock, key, and you have the display drive selection to select the gears, and you have the parking log, you have the speed sensors, you have the gear controller, you have the turbine sensor, you have the post area network controlling the transmission control unit called PCU. Okay, let us see a very important application with respect to some of the design aspects. Okay, so you have different type of gears basically, right? You have spur gear, helical gear, you have a spiral bevel helical gears, bevel gears, you have spur gears, spur bevel gears. You have very different number of gears basically, and you also know about all these things. Okay, I'm not going to cover this type of gears, but what I'm going to cover here is I'm going to cover some of design aspects of the gear. Okay. Basically, the gear has been designed considering the kinematics and also based on the force which is going to act on, and also based on the strength of the gears, okay, and also the surface which is going to get on. So these are different type of gears. Basically, we need to select for a different application. Let us see how the design is been carried out with respect to the gear point of view. You have a gear nomenclature. This is the nomenclature of a gear. This also you might be knowing. Let us go to the design aspects. Here, when you're going for a design, what do you consider is the velocity ratio, which is defined as angular velocity, what we have seen omega 1 by omega 2. And even you can also consider the PCD, pitch circuit diameter of the input gear to the output gear. You also have a torque ratio, which is nothing but the torque which is going to get acting at the output side and to that of the input gear. And we have seen this gear ratio as well. And here the gear ratio is always almost always greater than 1. And whenever you go for any design of a gearbox or gear, so what we do is we follow this law of gearing, which says that the common normal, the tooth profile what we have seen, which is going to have at all points within the mesh, it will always pass through a fixed point on the line of the centers. It is called as a pitch point. You have a gear set velocity ratio, basically the velocity ratio will be constant throughout the mesh, and again it is also equal to the gear radius. So the gear radius, the ratio of the gear radius, which means the gear ratio and the velocity ratio will be always same. And when you're going for a American Gear Manufacturing Association AGMA standards or specifications, you have different parameters when you are going for the addendum depth, working depth, or a depth or the thickness of the gear selection, or what should be the clearance, and what should be the circle pitch. So you have the values which has been already been defined by AGMA, and you need to follow this for a coarse pitch and also for a fine pitch. You need to follow this design guidelines, and you need to go for a design specification. And similarly, these are all the different standard gear teeth which are available for an automotive application, where you have three different category. Either the angle can be the gear angle. It can be either 20-degree full depth or 20-degree stub or 25-degree full depth. So according to this, you have a different teeth thickness of the gear, and depth will vary accordingly. The clearance will vary accordingly. The addendum and the dedendum values will also vary accordingly. Even the face width, this is very important one. But whatever it is, irrespective of the angle, face width lies between 9 ratio between 9 by p, means it lies between the value called b. B is nothing but the face width, where it is dependent between 9 by p to 13 by p, where p is nothing but the pitch. So again, considering all this, you look for 10 aspects. And when it comes to the gear, so we need to understand what type of gear we are going for it, and what is the different type of terminologies or what is the nomenclature that we need to look, and what are the forces it's going to get acting onto the gear. That is important, and accordingly you need to design the gearbox. That's why I also told you you have different number of gears. Sometimes 4-speed, 5-speed, 6-speed. Accordingly, the design will also vary. But what is important is the force getting transmitted to the gears is very much important. Because if you are not selecting the material, or if you're not selecting the type of the gear which will withstand your force, then it will lead to the failure. At the same time, it will lead to the breakage as well. These are the two type of gear: driver gear and also driven gear, where we call pinion gear as a driver and the driven gear, driven as a gear, basically driven gear. And the small gear we call it a pinion, and large one what we call is a gear, basically. And in most of the application, the pinion is going to be the driver. So this is the pinion. This is going to be the pinion, and this will reduce the speed, but it also increases the torque. And so we need to follow the law of gearing. What I was telling, the law of gearing, you have to follow those things when you're going for a design application. When you're going for the design aspects of the gear, you need to follow this. Yeah. The very important thing when you are going for a design, what normally we do is we look for a strength purpose. Okay, we need to select the gear tooth considering the bending strength, okay? And you need to ensure that this strength is very much required, so that there will not be any breakage of the gear tooth during the running in of the gears. Because you have different load which is going to get acting onto the gears, and accordingly you need to select the design parameters using these formulas. And whatever the stress which is going to act, okay, it should not exceed the allowable stress. And this is the allowable stress formula, where you have the ST into KL by KT by KR, where ST is nothing but a bending strength into you also have the life factor, the value, and again this life factor will also vary with respect to the different conditions, which we will see it now. You have a KT and KR. KR stands for reliability factor, and KT is nothing but the temperature factor. And we have these values KL, KT, KR will vary with respect to different parameters. But what is in our hand is, in our hand you have the bending strength. Okay, so this bending strength, whatever the overall stress should not exceed the allowable stress. Okay, so I told you the factors is going to get varied, right? So according to the power and then the load which is going to get acting onto the gears, you have the different factors. Okay, and you see this is again going to be even this also depends on some of the dynamic application, the load basically. Accordingly, the factor will also vary. And this is the load distribution factor called Km. And according to the load which is going to get, and again you see here, it depends on the various scenario. It can be with respect to the the mounting aspects, or it can be with respect to the contact aspects, or it can be with respect to the accuracy aspects. Accordingly, you have different factors to determine the load, and you have the reliability factor called KR. And again, this value also will vary considering the different aspects, and we also need to follow DAGMA standard when you're going for the design. And you need to follow DAGMA geometry when you're going for a selection of the gears. What should be the number of teeth? What should be the bending strength? And always remember that the allowable stress should not exceed the limit. Basically, the bending stress should not exceed the allowable stress, and that's where you take utmost care to ensure that. And again, the selection of the material is also very much important. Accordingly, the bending stress will also increase. See, when you're going for a material where the grade is going to be grade 2, you have the bending stress higher. And when you're going for a grade 1, the bending stress is going to be lesser. And again, you have a true hardened steel gear, and where you have the grade 1 for a good quality and grade 2 for a premium quality. These are different factors. Okay, so we have seen this planetary gears already. We have seen a video as well. Okay. For this planetary gear, where you have the angular velocity of the gear, which is equal to the angular velocity of the car, along with the angular velocity of the gear. Okay, this is the approach that we need to look when you're going for a velocity analysis. And when you're going for a velocity analysis, we always consider the sun gear in the center, and we have the planet gear, okay, N1, N2, N3, and we have the ring gear. And we consider all the velocity at which it is different gear is rotating. And even when you're going for a compound gear or a compound planetary, where you have a small sun gear and also the large sun gear, accordingly, you will have one more omega there. So you need to consider this. Considering that, you select what should be the number of teeth with respect to your sun gear, planet gear, ring gear, and then what should be the speed, angular velocity, and accordingly you design it. This is very important. The failures. You have different type of failures, which is going to happen if you are not going to follow the AGMA standard, or if you're not following the design. If you're not following that, then the failures will happen with respect to many aspects. The first failure can be the drive shaft getting failed through bending when it is after overspeed. Let us see some of the failures and the modes of the failures as well. Okay, let's see some of the modes of the failures. And let us. Okay, these are some of the typical gearbox failures, where we have seen a shaft fatigue failure because of non-proper lubrication. You also have some of the shaft failure, which is coming from torsion overload, and even you have a shaft failure because of the fatigue. And again, you have these are different type of gearbox getting failed with respect to the crack point of view. Okay, when we do the SEM analysis, scanning electron microscope, where we be zooming it to 1000 micron, and we zoom it, and then we see what type of failure is going to be happen. Is it going to be the fatigue failure, or is it because of the material failure? So what type of failure we are going to get? And even these are some of the gearbox failures where the bearings will fail, and you have the drive shaft joint failure. Again, you also have the bearing failure because of the poor lubrication as well. And even the gearbox casings will fail because of the structural stability, because of the material issues. And even you have the casing failure because of the overload. The load acting is going to be more, again the failure can happen. And these are some of the test rig basically. It's not that the failure will happen only to the gearbox or transmission alone. Even some of the tests which is going to happen in-house with respect to the help of the test rig, even there you're also going to have some of the failures where rolling element bearings raise failure through an electric discharge as well. So this is very important thing, like where you have different failure modes of a gearbox, and then what can be the failure modes? What are different failures and then failure modes? Okay, when the gearbox is, say for example, going to have high speed shaft assembly, where you have the bearing fatigue, and this failure mode is because of this. Because of this fatigue, gear fatigue, you are going to have the gearbox failure. And again, it is applicable for a low speed intermediate shaft, or it can be applicable for a high speed intermediate, high speed shaft, or even for a low speed shaft. Um, you have different failure. One can be a fatigue failure of the gear or the bearing fatigue failure as well. And even the overload of the bearing also can happen. They can also create a failure. And let us take one example. Let us take a primary gear where the requirement is to transmit torque. Suppose here, what can be the failure mode? The failure mode here is the jam on the primary gear axis. What can be the failure effects? Okay, the failure effect is no torque transmission from the servo motor to the throttle. And again, the throttle here, when I say the torque transmission from the servo motor to the throttle is going to be the sludges, and we have the risk priority number called RPN, which is the product of severity, occurrence, and detection. Higher the value, you always take some corrective action to understand what is the failure cause, what is how you can prevent the failure, and what type of detection control you have either to do go for some more testing. And this is one application where you go for a failure mode considering the jam onto the primary gear, and even there can be some of the brakes in the gearing area, and the reason can be the failure effects can be the no torque transmission from the servo motor to the throttle. And the same thing follows here, and where you have some other causes as well. The failure cause can also be because of too large a length. That if the tolerance length is going, the length tolerance is chosen in high value, then even the failure can happen. Then if the surfaces in the bearing position are too rough, then there can be a jam on the bearing position in the housing, which will result in the failure of the primary gear as well. So there can be n number of failures that you need to understand. And but when it comes to the material or a structural failure, it's very important that you can avoid all those things with the help of a design, proper selection of design, where you follow the proper velocity ratio, gear ratio, law of gearing, material of the selection with respect to the grade 1, grade 2, what we have seen. Considering this, we can avoid those failures, and we always better to follow the AGMA standard. Okay, again, it's not that this alone matters. AGMA is very much important because that is where you need to select what should be the face weight, what should be the thickness, what should be the geometry of the gear. Okay, all this will contribute to the better performance of the gearbox. Yeah, and when I say transmission, it's not only going to be with respect to gearbox alone, but the complete transmission, even you have with respect to the final gear or the final drive ratio as well. Even there can be some of the failure even with respect to the differential point of view when you are considering the transmission failure mode effect analysis. But today our scope is going to be only gearbox, so that's why I'm going to restrict only to the gearboxes alone, where we have seen some of the examples because of the bearing overload issue, those failures. And let us see one more failure mode with respect to the gear teeth breakage for a planetary gear. Okay, where the potential effect of failure is going to be the transmission is going to be inoperative, and the potential cause is going to be the excessive torque, and you have the load, and the duration is also going to be too long. And this is applicable for automatic transmission, where you have where you need to have some prevention control, and also you need to have some detection control. How you can prevent the control of the gear getting break in the case of planted gear? It is by going for a minimum excessive load when you're especially when you're towing the vehicle, and you can avoid the excessive temperature so that you can also avoid the failure. So you have some of the testing methods, very important for a gearbox. What type of test we normally do? We do the test with respect to the complete vehicle, also with respect to gearbox. See, this is the system level, and subsystem you have the casing, gears, synchronizer, you have the internal system, you have external system, you have the clutch system. You have individual tests usually. You have the installation, you have the vehicle interface. When it comes to the component level, almost all the components are getting tested. Okay, so gear shafts, bearing seals, because all these are the one which will lead to failure as well. And if there is insufficient lubrication, then again the failure can happen. And synchronizer, if in case any breakage in the synchronizer sleeve or hub or a ring, again the failure can happen. Okay, so that's why it's very important to do the testing to ensure that the durability is not going to get affected. You need to go for a test which is going to prevent the failure, and it will also detect the failure. Okay, it will detect what type of failure is going to happen, and accordingly you can take some corrective actions. These are the different type of gearbox testing for a component level. This is for a synchronizer test. You also have the park plug testing, where they are carried out with the help of the equipments, and you have the assembly test for the lubrication purpose. When the vehicle is running up the hill or down the hill or different altitude, different curvature, so you you need to ensure that uh, the tilting of the gearbox, okay, when it is getting tilted, okay, how the flow of the oil for lubrication. If in case any insufficient lubrication, then again that will also lead to the failure, right? So that's why you need to do some testing to ensure that those failure is also not going to happen. And you have different tests, which is this is very important slide for you. You have the testing of gearbox, where the test is carried out in the bench level, rig level, and you have different rig like spin rig, driveline rig, and also powertrain rig, and even the vehicle is being the test is being carried out in the vehicle. And this type of test is very much important to confirm the design, the function, and also performance, durability, and also performance of the vehicle. And when I say the bench level, it will confirm only the design and function. When it comes to the rig level, it confirms the performance as well. At the same time, when it comes to the driveline, it also confirms the durability. Because our focus is towards the driveline and also the powertrain. Because this comes, gearbox is a part of this. Finally, as a vehicle, you need to ensure that overall durability, performance, functions, and design is going to get met. And you have various types of tests for a transmission basically. So clutch is a part of transmission, where you do clutch bus tests, you have hysteresis tests, you have various tests basically. When it comes to the even you have the lubrication test which I was showing, you have a gear marking test. Okay? This is, and you also have a gear design life test as well. And you do the transmission drive cycle test for 50 hours. You have some of the double engagement test. You also do some tests with respect to the torsional rigidity test, and you will do some related to the wheel test. All these tests will ensure that the failure is not going to happen. Even the functional rig test. This is all the part of the functional rig test, and you have the durability rig test, where you shift you shift the gears from 1 to 2, 2 to 3, 3 to 1. You change it with different frequency, and you do it for different hours, different periods. And here you will also ensure that you are going to complete the shift system test, the fork durability test, the endurance oil pump. Basically, you will pump the oil. You also do this test and lubrication purpose. Even you do some other tests with respect to the clutch as well. You do the temperature sensor, pressure test, the shaft failure test. You also run the vehicle at a top gear. Okay, And we also give the different load, 25% load, 50% load, 75% load onto the gears to ensure that the gear is not going to fail. This is the four-wheel drive testing method, which is a snapshot of the testing which is going to take place with the help of the dynamometer. And this is the four-wheel drive testing, where they are going to measure the overall the performance of the gears with respect to the dynamometer condition. And here they have the different sensors to ensure that to monitor the different parameters, and they have the complete control system, testing system, which is going to be electronically controlled. This is one of the example of a power takeoff testing. This is basically for one of the tractor application basically. When you have the testing with respect to the motorcycle drive shaft test and the oil pump noise test. Okay, this is for a complete transmission. Okay, it's not only gearbox but the transmission. This is for a gearbox where you are going to test the small gearbox. Even you have the large gearbox, we are going to test it with the help of the dynamometer. And you also measure what is the deflection. Okay, what is the movement you are going to get when the load is going to get acted on the various portion in the transmission and also in the gearbox. And when it comes to the powertrain, you also test with respect to the deflections. Deflection means how much movement is going to happen because of the load, whether the deflection is going to be within the limit or not. And you have the testing agencies called Ricardo. Is also one of the leading consulting organization with respect to the engine and transmission application. Okay, so these are all the things. Thanks a lot for an opportunity. You can email me if you have any queries, or you can also ask me now.
Thank you.
Yes, sir. Yeah,
Yes,
my
sir.
mail ID is yes, sir. My mail ID is P.Arjunraj@gmail.com. Thanks a lot, and I look forward for some out of questions.
Thank you, sir. Thank you, sir. Thank you for your detailed and useful information, sir. Informative session, sir. It's really nice, sir. You have covered all the parts of design, development, and testing of automotive gearbox, sir. It's a really nice one, sir. You really